Another reason we need to be a little bit careful in using the eutectic is we need to realize that not all chemicals have well-defined eutectics. This is because not all chemicals have well-defined freezing points. In particular, this happens with organic chemicals. So some of the commonly used chemicals in organic-based performance enhancers are things like glycols, carbohydrates, proteins. And these chemicals often have a property that's known as cryoprotection. Now, cryoprotection is a pretty interesting property. What a cryoprotectant does is it will lower the apparent freezing point of water when you dissolve it, but it doesn't lower the true freezing point. Now, what do I mean by that? It gets back to what I was talking about a moment ago when I talked about thermodynamic versus kinetic factors. The thermodynamic factors have to do with how low the true freezing point is. Now, you can add a little bit of a cryoprotectant to water, and it's not enough to drop the true freezing point very much. However, it will interfere with the rate. It will slow down the freezing process. So you can drop that solution below its freezing point, and it will freeze so slowly that you can't see it. Now, typically, or very often, what will happen in a case like this is when you cool the brine down, instead of having a well-defined point where it starts freezing and you can start seeing ice crystals form, what you'll see is it'll just start getting thick. It'll start getting more and more viscous. That's a typical sign of a cryoprotectant. Now, let me show you what effect that has when we try measuring the eutectic. The way that we measure freezing points for de-icing liquids is with a standard ASTM test. And what we do is we measure a cooling curve. And what you do is you take the de-icing liquid, you put it in a cold bath, and all you do is you basically watch how the temperature changes. So if you take a look at the graph here, you'll see a typical cooling curve for liquid magnesium chloride de-icer. And watch what happens. Note that the temperature drops very steadily, and then at a certain point there's a very definite break in that cooling curve. Where that break occurs is a very accurate measurement often of the freezing point. Now watch what happens if we take the same brine but blend it with 25% of an organic-based performance enhancer. Now the red line you see is that same magnesium chloride brine, but now with the organic-based performance enhancer added. And note, we've completely lost that well-defined break in the freezing point curve, or I'm sorry, in the cooling curve. So does that mean that the liquid has no freezing point? No, it does not. There is still a freezing point there, but measuring it is being interfered with by that cryoprotectant additive. Now watch what happens if we try measuring a eutectic curve in the presence of these cryoprotectant additives. Because we cannot measure an accurate freezing point, it prevents us from measuring an accurate eutectic. So this shows you an example of the freezing point curve measured for plain magnesium chloride brine, which is my red line, and that magnesium chloride brine blended with 25% of an organic performance enhancer. The red line, you can see, has got a very nice typical V shape. So I can very readily pick out where that lowest freezing point is in my eutectic. Now, my blue line, on the other hand, you can see I've completely lost that well-defined V shape. My apparent freezing point just keeps dropping and dropping and dropping. So the moral of the story here is that when we've got liquid de-icers that contain organic additives, we just need to bear in mind that those organic additives can interfere with the standard tests that are used to measure freezing point, and they can give us inaccurately low estimates of the eutectic temperature.